In our final video, I wanted to bring everything together and just show you an example of how we can handle that first Guinness beer example with a one-sample t-test. Now, one-sample t-test is looking at the situation where we're testing a null hypothesis that the mean for some normal random variable is equal to mu naught versus the alternative that mu lies in some other sample set lambda, which, this could take into account a two-sided null hypothesis or a one-sided. We're going to write out everything in this slide in terms of the two-sided mu not equal to mu naught, but you can make the appropriate adjustments for one-sided alternatives as well. Now, the idea is, as we mentioned before, that the test statistic we're going to use is t equals y bar minus mu over s divided by square root of n, right? The test statistic that would be normal if I knew the population SD. And we're going to reject the null hypothesis if the absolute value of t is greater than or equal to some t star, where t star is the appropriate critical value that we need to get a desired significance level for our test, right? So for example, if we're looking at significance level of 0.05, this is sort of how those critical values compare to the typical 1.96 that you're used to for the normal distribution under this scenario. We can see that for 1 degrees of freedom, the critical value is huge, over 12, but it pretty quickly drops down to something near 2. In fact, by the time you get to degrees of freedom of around 25, 26, you're within kind of like a 5% margin of error of the normal distribution. So I wanted to return to our initial example where we were collecting a sample of 5 random beers from a new batch, and we were trying to test to see if the mean for that new batch was equal to what it should be, right? With the understanding that if it's not, then we're going to reject this batch and check out what's going on, or maybe test some more beers at least. That wouldn't be so bad, and see what's happening. I wanted to show you how to do this in R, and I also wanted to note that we're going to be using our standard 0.05 significance level throughout that analysis. So to perform this hypothesis test, I went ahead and opened up RStudio and entered the 5 ABV measurements as a vector ABVS, and they're listed below here. To find the critical value for the hypothesis test, we can use the QT function. What a QT in RStudio. So the way the QT works is first you enter the desired percentile. So for a 0.05 significance level, that's going to be 0.975. And then you enter the degrees of freedom, which is going to be n minus 1 or 4 in our case. So that tells us that once I compute the t-statistic, if its absolute value is greater than 2.77, then we should reject the null hypothesis and conclude that this batch is somehow defective or something's wrong with this batch. Notice how much higher this is than the 1.96 we would have gotten if we just used the normal distribution. So finally, we compute out the t-statistic. So we're going to take the mean of our sample minus the mean under the null hypothesis divided by the SD of our sample over square root of our sample size. And let's see what comes out to be. It is negative 5.65. Wow, so certainly bigger than this in absolute value, which means we are going to reject the null in this case and conclude that this batch of Guinness is not appropriate for St. Paddy's Day.